Evening. I'm Spot On Weather meteorologist Matthew Euler, and welcome to a special video. I'm going to delve into a couple winter themed videos here coming up. I took a little bit of a break from the Teleconnections discussion this past Friday night, and my plan is to resume those for next weekend. But in the meantime, since the weather is fairly quiet across the mid-Atlantic and the eastern US, I decided to do three special weather themed videos. The first one is going to be the brutally harsh winters of the late 1970s. I'm going to take a review of what went on in that particular period of time for the winter seasons. And then I'm going to delve more specifically into Hampton Roads, Virginia past winter seasons. I'm just kind of looking at the past big winter snow events. And then I'll finally conclude with a video on it's titled "They Don't Make Winters Like This Anymore," and it's going to be a conglomeration of all the data, not just the late 1970s, but I'm going to delve into the other colder and snowier decades, including the 1960s, and compare that to the trends and how things are going and progressing in the winter season in the Northern Hemisphere. This particular photo is from the 1978 blizzard, one of the blizzards there in 1978. This is the interstate there up in around the Boston, Massachusetts area. I mean, can you imagine the snow coming down this hard to where, you just have to leave your car on the interstate like this? I mean, that's some pretty significantly heavy snow that leaves you with very little time to basically get home when the roads are this jam-packed and the conditions get this bad on the roads. So let's go ahead and take a look at the first of three special videos, winter-themed videos. I like to do these. I've done a lot of research in constructing these. So let's take a look. Okay, first thing I want to say is, I talk with a coworker, and all he says to me, he says, he's an older gentleman, a little bit older gentleman, and all he tells me is about the 1970s and how much colder it was, and the Time magazine covers that occurred during the late 1970s because the weather was so brutally cold from the Midwest to the East Coast. These were some of the Time magazine covers from the late 1970s. I mean, this one on the far left gives you instructions on how to survive the coming ice age. The next one, the next Time magazine cover here to the right, is the cooling of America, showing these people bundled up inside their home near a fire. And then this one, Time magazine cover, the big freeze, showing a gentleman there in his chair smoking a cigar. The cigar is frozen. And then finally, look at the one on the right here. This is the big freeze. So specifically in the late 1970s, these were the kind of things that were happening with the weather. Overall, the purpose of this research is to examine the colder than normal winters across the eastern U.S. from 1976 to 1979 specifically. That's the winters we're going to take a look at. We'll examine various data to determine the potential causes and weather pattern associated with such a cold period. So let's get right into a further discussion on this. We're going to start off by taking a look at the actual winter temperature anomalies, starting with the winter of 1976-77 here on the left. This scale here on the bottom shows the departure from normal in degrees Fahrenheit. Generally showing you that the aqua coloring, the blue coloring, the green coloring indicate below normal temperatures, while the yellow and the orange coloring, you can see on the scale here, are on the positive side of things, indicate warmer than normal temperatures. So when I talk about the winter season too, before I move on, it refers to December to February, the beginning of December to the end of February, basically the meteorological winter classification. Looking at 1976-77 here on the left, look at how much below normal conditions were across the Midwest to the East Coast, even up to New England, even all the way down south to Florida in the winter of 76-77. I'll throw some key highlights of each of these winters too, so you can kind of get a feel of, what were some of these statistics behind these winters. Look at how much below normal the Ohio Valley was. Ohio, southern Indiana, Kentucky, into West Virginia, western PA. This was the heart of the coldest temperatures for that particular winter. We look at the winter of 77-78 here on the right, and you definitely notice right from the Rockies all the way to the East Coast, we have below normal temperatures. And again, The following winter, even after the 76-77 winter, the 77-78, look at where the heart of the coldest temperatures are. Generally around the same area of the Ohio River Valley, including parts of Kentucky, or pretty much all of Kentucky in this case. Meanwhile, much above normal temperatures are west of the Rocky Mountains, all the way to the west coast in the winter of 77-78. Looking at the 78-79 winter temperature anomalies, whoa, what happened here? Like, look at this. So in the 76-77, we're looking at the white coloring indicates near normal temperatures. And then we get to the 77-78 winter here on the right, and notice how much above normal the temperatures were across Oregon, Northern California, into parts of Nevada. And then we turn the page to 78-79, and look at this. The whole United States ended up with a below normal temperature regime in the winter of 78-79. This is incredible. This just doesn't happen very often, and that's why I say it's incredible. Because it's dependent on the wavelengths of the long wave pattern in the jet stream. Like, what are those wavelength distance? How much is that covering? In this case, the whole United States was colder than normal outside of Central and South Florida. Okay, well, they had near normal temperatures for that winter. So this was an incredibly phenomenal period of time, the 76 to the 79 time frame in the winter seasons across the United States. This is very widespread cold, very remarkable. Now let's take a look at some of the teleconnections on those winters, 76 to 79. We're going to start off with the North Atlantic Oscillation, the NAO here on the left. Notice the blue bars here indicating a negative NAO. The red bars, if they go above into the red coloring, that indicates above positive NAOs. And notice right here where I circled, the late 1970 winters predominantly were seeing a negative NAO. Specifically, the winter of 76, specifically in the early 1977, in the January, February, March time period. And then you see below a negative again here, 78. So a predominantly negative NAO occurred during the late 1970 winters. If you look at the right here, we show an Arctic oscillation, or AO, and very much similar to the NAO, we have a pretty large amplitude negative phase to the NAO. And that basically, for the AO goes all the way from the 1976, early 77 out through the late 1978 time period. We had a predominantly negative AO. So a negative NAO, a negative AO. For the Pacific North American pattern and the MJO Teleconnections, I got MJO coming up. So in this slide, I'm just going to show you the Pacific North American, and then I will show the MJO and what it looked like. Look at the amplitude of the late 1970s of the Pacific North American pattern, the PNA pattern. We had a sharply positive PNA pattern, which existed, predominantly positive PNA really, but this amplitude here of the late 1970s of the PNA featured very strong ridging right along the west coast of North America, and that positive PNA with that downstream troughing across the eastern U.S. Let's look at the MJO, the Madden-Julian Oscillation Teleconnections from January 1976 and January 1977 here. On the left here, I want you to realize that the red line is indicative of the actual MJO and what it did. And so in January of 1976, you see the amplitude. I've talked about this in my teleconnections discussions. The further away you get from this inner smaller circle, the stronger the amplitude or the phase of the MJO, and the greater the sensible impacts on the weather. And so basically mid-January, the MJO was starting to work its way outward to greater amplitude. By the 19th of January, it was sitting in this position of phase 6. And then it just worked its way in a counterclockwise rotation into phase 7 by the 25th and 26th of January 1976, all the way over into the colder phase of phase 8. Look at the amplitude of phase 8 here from January 27th right on through into the green line is February, early February. So this was very active MJO, significant amplitude in January 1976. And you get into those colder phases, 8, specifically 8, you're going to see some very cold temps across the eastern U.S. Now, if you look at the image here on the right, In January of 1977, the red line again indicates January in the behavior of the MJO. It went into a little bit of the phase 6, but mostly in phase 7 it was weaker than the previous January, and then it rotated back into the null phase before coming out in phases 2 and 3, where we had the convection enhanced precipitation in the Indian Ocean. So a little bit of different flavor here, less active, lower amplitude in January of 77. If I look at January 78 here on the left for the MJO, again, the red line is indicative of the MJO. And look how strongly amplified this MJO was, how active it was. The convection across the Indian Ocean, specifically into phase 3, as we went into mid-January and just beyond into the third week of January. And then the MJO rotated into phase 4, where we had convection in the maritime continent, and then into phase 5. And then by the time we got to February, this got interesting in February because we had major blizzards going on. Specifically, that cover slide I showed you around the Boston, Massachusetts, New England area. Look at this, phase 6, then it rotated to phase 7, very amplified MJO, into phase 8 by the end of February. Okay, so very different looks here to the Madden-Julian oscillation in these particular colder than normal winters. Graphic here on the right showing, again, the red line indicates January of 1979, showing how it started off fairly weak in phase 6, and then it kind of was weaker into phase 7 before coming back out in a greater amplitude here in phase 7 with convection across the western Pacific in January of 79, and then it rotates around counterclockwise into phase 8 by the 20th of January. Basically a 4-day period where this was really in the colder phase of the MJO in January of 79. What about solar activity in these particular winters in the late 1970s? Here is, these numbers, by the way, indicate the solar cycle number. So during basically from 1970 to the late 70s, we were in solar cycle 20, and then the solar cycle picked up basically in phase, or solar cycle 21, there around 1977-78. So we had a lull in the solar activity around 1976, and then you see how this graph climbed up, right? That indicates we're going to more active solar activity as we worked our way towards 1977, 78, and 79. And then it reached a peak around 1980. So in general, lower solar activity, then increasing in the late 1970s. So why is solar activity so important? Okay. The lower the solar activity, research has indicated, leads to greater frequency of high latitude blocking. And that high latitude blocking tends to lead to anomalously warmer air reaching higher latitudes further north in the northern hemisphere. And that on the front side of those major upper level blocking patterns, you get these anomalously deep trough, a more meridional jet stream, and those winds tend to weaken in the jet stream overall. You get anomalously colder outbreaks of air that come in from the Arctic, almost like a direct cross-polar flow situation. So solar activity in the late 70s, here you go. Took a look at that. Now let's look at the sea surface temperature anomalies, and I did snapshots of the Decembers. This is December 1976, and you can see the scale in degrees Celsius, the anomalies here on the bottom. If you see yellow and orange coloring, that indicates above normal water temperatures. If you see blue coloring, that indicates below normal water temperatures. And one thing that I'm going to really highlight in my third special winter theme video, they don't make winters like this anymore, is I'm going to really get to the point of how you're going to see the differences between the late 1970s and the present time as far as how the oceans have warmed significantly since the late 1970s. This is December 1976. And so the major features I'm looking at here in the Pacific, North Pacific, we have below normal water temperatures in the order of 1 degree Celsius. And then we have above normal water temperatures right off the immediate west coast from British Columbia down to Baja. Off the coast of California, you have 1 degree Celsius above normal water temps in December 76. You do have a look of above normal water there in the eastern equatorial, central equatorial Pacific area. Not a widespread area of above normal water temperatures, but nonetheless it's there. And then look at the Atlantic. This is impressive. Look how much below normal conditions were across the Atlantic as far as the water temperatures off Nova Scotia specifically, right down the east coast. And then even below normal in the Gulf of Mexico in December of 1976. Looking at December 1977 now. Let's see what's changed. Well, we don't have that warmer than normal water off the west coast now anymore. It's actually returned to more normal levels, the water temperatures. We do see below normal temperatures there, water temps across the Gulf of Alaska at 1 degree Celsius below normal. And then we see a cooler pool of water across the general central Pacific northwest of the Hawaiian Islands. And then we do see a weak signature of warmer than normal temperatures there across the equatorial central Pacific Ocean. And then look at the Atlantic still. The North Atlantic is still below normal on the order of 1 degree Celsius below normal water across the North Atlantic. What about December 1978? Well, let's see. Now we've switched to below normal water temperatures off the U.S. West Coast, specifically all the way up off British Columbia down to Baja. We do have a pocket of warmer than normal temperatures in the order of 0.5 to 1 degree Celsius above normal water anomalies there to just generally the west of the Northern California coast. Cooler than normal water rules the day, even down into the West Pacific. Notice that warmer than normal water kind of disappeared across the equatorial central Pacific in December of 78. And then we actually have above normal water temperatures stretching from New Jersey southward along the east coast, including parts of the west coast of Florida and the Gulf of Mexico. And then there's that below normal water again across the North Atlantic. So it appears that there was a theme of below normal water across the North Atlantic in each of these particular Decembers, 76, 77, 78. All right, so now let's take a look at some of the weather highlights. And if you were, if you're a little bit older and you remember this type of weather, maybe you were a kid at this time, hopefully you enjoyed this video, kind of just reliving some of the winters. 76, 77, the winter season highlights. Obviously, it was a very frigid temperature regime across the eastern U.S. in this particular winter. January 1977 was the coldest month in 200 years across the eastern U.S. I mean, that's saying something. 200 years. Temperatures averaged 19 degrees Fahrenheit below normal. 19 degrees Fahrenheit below normal temps in the heart of the Ohio River Valley, specifically even back to the west of Illinois, Indiana, and Ohio in January. And in January, look what happened. The Ohio River froze over at Cincinnati. This resulted in 8 to 12 inch thick ice, and lots of people were just crossing the Ohio River. And it hasn't, it's only become frozen like this over a limited number of times in history. And so that just goes to show you, these people are literally walking across the Ohio River. It's a complete solid sheet of ice. Here is what the upper level pattern looked like, the 500 millibar height pattern in this particular winter season. And you see a deep area of low pressure over the Hudson Bay area. There is a anomalously strong upper level high parked just off the U.S. west coast, off the west coast of Canada. And so we have this huge upper level ridge working its way all the way up into parts of Alaska in the winter of 76, 77. With just this cross-polar flow between this upper high off the Pacific Northwest and this deep low over Hudson Bay, directing northwesterly winds from the Arctic, from Siberia, cross-polar flow all the way down into the Midwest and into parts of the eastern seaboard in New England. And this was a persistent pattern, persistent theme. Here are the specific reasons why it was so cold in the winter of 76, 77. There was that anomalously strong positive P&A pattern, so we had a major upper level ridge, highly amplified, generally in this position as I indicated here on this slide, just off the west coast of the United States. And then we had a major downstream trough over the eastern U.S., just directing colder air from the Arctic into the eastern U.S. And what's so surprising about this pattern, and you just don't see this much anymore, is this anomalously strong positive P&A pattern. This took hold from October all the way through late February. For the most part, things didn't change. You look at the patterns these days, and your upper air pattern, you might get a temporary period of colder than normal temps in the winter, and those do eventually get replaced sometimes when the pattern flips to a ridge in the east, and that brings that milder air back in. But in the winter of 76, 77, that cold was persistent because the pattern was locked in place. There was that large upper level low, as I mentioned in the previous slide, over Hudson Bay, over eastern Canada, generally in this position. And that pressure difference between the upper level low and the upper level high directed that flow of air straight down into the United States from the Arctic area. And again, the remarkable consistency is really the main thing, the main theme for the winter of 76, 77. Cold Arctic air funneled southward from the Midwest to the East Coast repeatedly, more repetitively. Over the Arctic region, there was a strong blocking high in place in January. That displaced the polar vortex, that stratospheric polar vortex south of its usual position into southern Canada. And then there were long wave troughs which just deepened across the central Pacific and the eastern US. So basically the pattern, you had deep troughs. It's off this particular map here, but there was a deep upper level trough, and on the front side of that deep upper level trough over the central Pacific, you ended up getting milder wind regimes, and you got warmer temperatures, which pumped up this ridge even more just off the coast of western North America. All right, so here are the mean upper level heights. The one graphic here on the left is from October 1978, and then the graphic here on the right is January 1977. By the way, this material is courtesy of the American Meteorological Society, the monthly weather review publication from October 1978, and you can see the gentlemen who did the write-up on this, did this research, Henry F. Diaz and Robert G. Quayle. So I'm taking it directly from that particular journal. Look at what's going on here in October 1978. In general, what you have is a fairly strong polar front jet stream, not really anomalous in any regard. There is a trough over the Gulf of Alaska, but generally, we have a little bit of ridging along the U.S. west coast up to western Canada, but it's not very significant yet, but it's still there. You do have a positive PNA that has developed in October with a downstream trough across the Midwest and to the eastern U.S. By January of 77 here on the right, now this was impressive, this pattern. And again, this didn't budge, this didn't change. So you have this deep upper level low, that deep trough over the central Pacific, deep upper low, and that just pumped up the heights and fed some warm air advection into the backside of this long wave ridge, or actually no, this is a short wave ridge, right? We're looking at 500 millibars. So there's warm air advection on the backside of the short wave ridge. Look where the ridge axis is. From Seattle northward, right along coast of British Columbia, up into parts of eastern Alaska. All right, with a deep trough, there's that upper level low situated in eastern Canada, and the difference between the upper level ridge, the anomalous ridge, and that deep low allowed that colder northwest flow from the Arctic all the way into the United States. Now also notice one other feature here, that is an upper level high situated over the Arctic, over the North Pole, associated with some blocking. All right, now let's take a look at November 1976 here on the left. And you can see where that ridge axis is really setting up. Immediately right along the west coast of North America, from the Pacific Northwest all the way up into parts of the Yukon territories in the eastern Alaska. And you see the deep trough that has developed, very tight height gradient. And so you got the upper level low still situated over eastern Canada. The backside of the upper level low, you get a northwesterly wind trajectory and much colder air. December 1976 is over here on the right, showing a very similar pattern, upper level ridge, western North America, right along the coast, closed upper level low over Hudson Bay, and that strong, wow, this gradient is really tight. Look how closely packed these height contours are. And so you're getting a just persistent flow of cold Arctic air into the lower 48. Right, so we kind of know what happened in the winter of 76, 77. So now let's take a look at the winter of 77, 78. Now, some of the highlights from the winter. This was the first time for back-to-back severe winters across the eastern U.S., really since the 1903-04 and 1904-05 winters. There was a large anticyclone over the western portion of North America, along with deep troughs again over the Pacific Ocean and blocking highs over the Arctic on the Canadian side, responsible for extremely cold temperatures. Here's the 500 millibar height contours for January of 78. Look how anomalously high these heights are all the way up into Alaska. So you get this deep upper level low position just to the west of the Pacific Northwest. And you get, again, very anomalously strong ridging just off the coast of western North America up to Alaska. And then this amazingly deep flow, deep trough That wind flow is pretty much from the northwest, from the Arctic, from Siberia, and that cross-polar flow all the way down to the Midwest, New England, parts of the Mid-Atlantic in January of 78. I wanted to highlight one of the big weather events. I'll do this with a couple of these winters, and this was a blizzard of January 1978. By the way, here's the surface chart here on the left, and here's some upper level charts on the right. This is the surface analysis, by the way, for 26th of January 1978 at 12Z, early morning hours. There's a very intense area of low pressure situated generally in the vicinity of eastern lower Michigan. We have a very strong Arctic cold front which is extending southward from that area of low pressure down into parts of western Virginia, western North Carolina, into northern Georgia, all the way down to the Mobile, Alabama area into the Gulf of Mexico. There is a very strong Arctic high that's all the way down. I mean, look at this ridging, all the way down from the Canadian area, all the way down into eastern Texas. By the way, this low pressure produced the second lowest barometric pressure ever recorded in the contiguous U.S. for a non-tropical system. It's also known as the Cleveland Bomb. South Bend, Indiana had 3 feet of snow with this thing. Southern Michigan had 2 feet of snow. There was a complete shutdown of some of these cities with the drifts reported as high as 10 to 20 feet. If you look at these dark solid lines, these are your lines of equal barometric pressure. These are your isobars, and the tighter they are, closer they are packed together, the stronger the wind speeds. So just some crazy wind speeds here. You can see some of these station plots too. I mean, the temperature was down to, holy cow, you know, like 2 degrees above zero down to western Louisiana. This is some crazy cold air, folks. And then here are some of the upper level features. I want you to take a look at this. This is 850 millibar heights in the lower bottom left here. This is showing you how tightly wound this low is at 850. This closed low at 850 millibars or 5,000 feet is. This is just phenomenal. Just phenomenal energy in the atmosphere to work with. This was the 500 millibar heights with the upper level low just to the west of the surface low over lower Michigan. We just had a lot. I mean, it's just real interesting looking at these old charts. Another system a little bit later on in the winter was the blizzard of February 1978. I took a snippet of what the surface analysis looked like here on February 6th of 78. There was a 984 millibar low pressure system situated off Cape Cod. And this is just incredible wind right here. This is a very strong, intense system when you see these solid lines, these isobars packed so closely together. So this was a doozy of a storm for New England. Here's the upper level charts. Yeah, I mean, we had both jet streams that merged together to capture the storm and grow in intensity. We had a negatively tilted 500 millibar trough. And then look at the ridge. Look at the ridge here in February 6th of 78. Look how far north this ridge extends. It's up. The ridge is this upside down shaped U pattern with that deep trough across the east. And look at the totals. Snow totals here on the far right for the blizzard of 78 in New England. Places like Providence and Boston got 24 to 36 inches of snow plus. So we're talking 2 to 3 feet of snow in this area. And then additionally, there's 18 to 24 inches, a foot and a half to 2 feet all the way down into Kingston, Warwick, Bridgeport, Connecticut, New York City joined it. Look at eastern Long Island here, 24 to 28 inches of snow. Are you kidding me? Just impressive snowfall totals for the blizzard of 78. So let's look at the 78-79 winter season highlights. In general, most of the U.S. had below normal temperatures outside of Alaska. Is this a surprise? Alaska was warmer than normal. I mean, when you have a ridge like this, well to the north like that, it's not a shock that Alaska had above normal temperatures. Cold temperatures were noted for their widespread geographical coverage in this winter and the severity. 12 to 16 degree Fahrenheit below normal temperatures from the Rocky Mountains to the central Mississippi Valley. And this was the third consecutive or near record consecutive January across the central Mississippi Valley, the eastern parts of the Great Plains and western part of the Great Lakes area, as well as the Ohio Valley in the winter of 78-79. Okay. There was record high pressure in this particular winter. There was there's just an amazing record high pressure reading all the way down to Jacksonville, Florida. Okay, 30 degrees north latitude had a central pressure of 30.74 inches of mercury on the 4th of January. Just phenomenally high pressure for a location at 30 degrees latitude that far south. Chicago, by the way, in the winter of 78, 79. Oh my goodness. 88.4 inches of snow was recorded over the winter, with more than 47 inches of snow on the ground in late January, a record. 47 inches of snow. I want you to think about that. That's 4 feet of snow. Can you imagine just trying to get around that with that just sitting on the ground to do your normal daily work or business? I mean, just really incredible. This was the mean upper level height pattern in January of 79, showing this is 700 millibar level at 10,000 feet above the ground, and the theme is still the same. You get this is anomalously strong upper level ridge blocking pattern over western North America with a deep shortwave trough downstream of that into parts of the upper Midwest to the East Coast. By the way, this graphic is provided by also the American Meteorological Society, the monthly weather review publication. It was done by A. James Wagner in April of 79. So I just want to give my credit here. I'm sourcing it. But again, this is just phenomenal to look at these upper air charts and see what it looked like and what created all this cold air. One of the bigger events of that 78-79 winter was in January. This was a picture from Chicago. Okay, you had the CTA, Chicago Transport Authority, with their buses, trying to run their city buses. Good luck. Look at this. These cars are just pinned in with snow. Most likely what happened here is the snowplow, you see the snowplow back here, snowplow, probably just pushed the snow from the road right into these cars. So these cars are going to have fun digging out. I'm sure they did at the time. Chicago received 21 inches of snow from one 2-day period associated with this blizzard. And snow remained on the ground for 51 days, all the way to the 6th of March. The heaviest snow in this particular blizzard was, in fact, across the Midwest. And then in Milwaukee, look at this. This is creative. You know it's bad when you see Milwaukee, Wisconsin residents posting a sign that says, "Free snow, help yourself." I mean, that says something. They're used to snow in that part of the country. Another major storm, another one that impacted the East Coast, was the President's Day blizzard of 1979. Look at the impressive nature of this satellite image. Of course, it's not nearly as good as resolution as it is today, lower resolution, but wow, look at what it captured. An eye-like feature situated generally off the coast, just southeast of New Jersey, and then just this impressive look, this comma cloud structure to the storm. This is a super intense system. These were the snow totals with the President's Day blizzard of 79. It actually caught quite a few people off guard. It wasn't projected to get this intense, the storm. And of course, the computer weather models aren't nearly as good as they are today in capturing, the 3-day type forecast, 3-day window. But in general, you can see the coloring here. The white coloring, 4 to 10 inches of snow anywhere, and even went all the way down to North Georgia and to the Carolinas. If it's white area, it's 4 to 10 inches of snow. If it's a light blue area, it's 10 to 20 inches of snow. And then you see these pockets of dark blue, 20 to 30 inches of snowfall, folks. So this is really a major New England or a mid-Atlantic type storm by New England. Those were some of the snowfall totals, by the way, down here at the bottom. Philadelphia, Baltimore, New York City, over a foot. And then Dover, Delaware. Are you kidding me? 25 inches of snow in Dover. Baltimore, 19. And then even Richmond, down I-95 here in Virginia, had 11. So just impressive. What is the common theme for all these winters? We can look at analogs and pattern recognition to try to determine how our own sensible weather today is going to be. But what's the common theme of everything I showed you as far as the weather charts of those brutally cold winters of the late 1970s? And you gotta believe it. Right here, now I know this is January 2014, but this is just another example of an extremely cold eastern U.S. situation where you get the upper level ridge axis. This is 500 millibars, so we're looking at a shortwave ridge axis here, situated just along or just barely offshore of Oregon, the ridge axis off the coast of Washington State, off of British Columbia, all the way up into Alaska. When you have that ridge axis close to the immediate west coast, western coast of North America, You tend to get these deeper troughs, and even there's some ridging across the North Atlantic in this case, in, for example, January of 2014. So the position of this upper level ridge axis, bottom line, is super critical. The ridge axis is located along the U.S. West Coast and the Canadian West Coast, and this particular January. And the higher heights at the North Pole. Look at this. See how the higher pressure and the blocking is occurring over the North Pole as well. So the theme is there. I think that was it. Yeah, that was my last slide. Bottom line here is, it was a brutally cold period of time across the eastern U.S. And then even by the 78, 79 winter, when I showed you what it looked like right here. I mean, look at that. Almost the whole United States is below normal temperatures. And some of this actually spilled over to the early 1980s. And when I go into my comparison video of all the winters, when I look back at they don't make winters like this anymore video that's coming up. It's phenomenal to see. But anyway, that's all I've got for right now. I hope you enjoyed the video. Just taking a look back at past historical cold waves in the United States in previous winters. It's real interesting stuff. I continue to do some research into it. The weather can be a fickle thing for sure, the patterns, the way they set up, and sometimes they get stuck in certain patterns, sometimes they don't. So again, thank you so much for subscribing to the Spot on Weather YouTube channel. Hoping to have a Teleconnections discussion back up here soon. And in the meantime, I'll have 2 other winter themed videos to share with you after this video. I'm looking forward to sharing those videos with you, and I certainly again hope you enjoy the content of the channel. Till next time, everybody, take care and God bless everyone.